decompose the rational function as a sum of partial fractions. So we got a rational function here, 6 over x squared minus 9, so that went over here, and the bottom factors, 6 over x squared minus 9, the bottom factors, x squared minus 9, 9 is 3 squared, so we got a difference of 2 squares, that's x plus 3, x minus 3. That means this fraction can be written as a sum of two simpler fractions. So this will be on the bottom x plus 3 and x minus 3. Now we need to determine the numbers on the top so that we get 6. So let's say this one is A, we'll determine in a moment, and B. Okay, so basically we said it's part A. So we let this fraction be the sum of these two. Okay, so to determine A and B, let's do some work here. So if we combine these two fractions, that means we need to make common denominator. Okay, for that we multiply second fraction by x plus 3 over x plus 3. Here we would multiply by x minus 3 over x minus 3. That way the common denominator would be just x minus 3, x plus 3. Okay, x minus 3, x plus 3, which is when we multiply, we get back to original. I mean, that's what we have. So this implies then the bottoms will be same, then the top should be same as well. So 6 equals A times x minus 3 plus B times x plus 3. And we got bottoms, they are equal, so we are not writing. So when these two factors are distinct like this, x plus 3, x minus 3, so this is essentially A times x minus 3 plus B times x plus 3 equals the top 6. And this is true for all x. Now we can choose x equals some number so that we can isolate A and B. Okay, if we take x equals 3, 3 minus 3 is 0. So let's take this expression is true for any x, so we take x equals 3, let's say this one, then 6 equals 3 minus 3, 0, A times 0 is 0, plus B times 3 plus 3, 6, 6B. 6 equals 6B. If we divide both sides by 6, so B equals 1. In the same way, we can take x equals, let's make this 0, negative 3. That is then 6 equals A times negative 3 minus 3, negative 6. Negative 6A plus negative 3 plus 3 is 0. So negative 6A. Divide both sides by negative 6 to isolate A. Then 6 over negative 6 is negative 1. Okay, then done. Thus, this fraction 6 over x minus 9 is same as A over x plus 3, where A is negative 1. So negative 1 over x plus 3 plus B over B is 1. 1 over x minus 3. Okay. So this fraction, we decompose this complex fraction as a sum of two simpler fractions. Part B. So here we got x squared minus 2x over x minus 1. So here x minus 1, there is only, this is a prime. I mean, the bottom does not factor, just x minus 1. But this is improper fraction because the x is square on the top, on the bottom just x. Okay, so we can divide the top by bottom. You know, this is improper. Like when we are writing 5 over 3, let's say this one, then 3 goes 5 one times, remainder 2 and 3. So 5/3 is same as, in terms of whole number, 1 and 2/3. So let's do the same type of work. So long division, x squared minus 2x, we divide by x minus 1. Okay. So x goes x squared how many times? X times, because x times x is x squared. X times x is x squared minus x times 1 is minus x. Now we subtract here. Subtract means this positive becomes negative, negative becomes positive. Subtract means you distribute -1. So cancel. Here we got negative 2x plus x, so negative x. Oh, x still goes to x. X goes to x one time, but it's negative, so -1 times. -1 times x is negative x. -1 times -1 is positive 1. We subtract again. That means distribute -1, so this becomes positive, this becomes negative, cancel. Oh, that's -1 left over. That's the remainder. Okay, like the remainder goes on the top. So this is the quotient. So this fraction is indeed as x minus 1. By the way, let me write this in another form. So we know that this is 1 and 2/3. This can be written as 1 plus 2/3 as well. These are same. So we're gonna go in that route because we are supposed to write as a sum or difference of fractions. So x minus 1, that's the quotient, plus the remainder is -1 over the divisor is x minus 1. Okay, so this complex fraction is now sum or difference of 1, 2, 3 different terms. This negative positive is negative, by the way. I mean, we can do one more step, not needed, but this one is x minus 1. Here is minus 1 over x minus 1. Okay. Now the third is x over x squared plus x minus 2. So C is, so we let that x over x squared, I forgot the question, plus x minus 2. X squared plus x minus 2 is equal to, because the bottom factors is a degree 2 polynomial, so x squared minus x minus 2 plus x minus 2. I'm assuming it factors, okay? It might not, it does not have to, but this question is designed so it factors. So it's a trinomial. When it factors, it will be a product of binomials. I mean, you guys know in so many different ways how to factor. So I'm just showing you a trinomial as a product of two binomials. X squared is x, 2 is 2 times 1 to get plus in the bigger number and minus 1. And that's correct. So this one is now like part A, x plus 2 and x minus 1, some number on the top. So we let that, okay? Then, like last time, when these are distinct, this implies the top x equals a times x minus 1 plus b times x plus 2. It's like exactly like part A, okay? Now we want to get the values of a and b. If we take x equals 1, 1 minus 1, 0. Take x equals 1. This is 1 equals a times 1 minus 1, 0 plus b times 1 plus 2, 3. b times 3, 3b. Okay, that implies b equals what? 0 doesn't count. 1 equals 3b, so b equals 1/3. Now we take x equals, let's take -2, then -2 plus 2 is 0. So x is -2, a times -2 minus 1, -3a, and this is 0 by design because -2 plus 2 is 0. Divide by -3, so a is 2/3. So thus we can write this fraction x over x squared plus x minus 2 equals, okay, this fraction equals a over x plus 2. A is 2/3 over x plus 2 plus b is 1/3 over x minus 1. Okay, final.